Hey guys, this is Coach Lowe, and we are going to talk about Chapter 2, Section 6, which is algebraic proofs. Yay for proofs. This will be fun. These will be like puzzles, and you will love them, or you will learn to love them. All right, so some things that you learned last year in Algebra 1, and we're going to take what you learned in Algebra 1, and I don't want to hear any excuses, but we're going to take what you learned in Algebra 1, and we're going to put it with geometry, and we're going to talk about proofs, like why you did what you did last year. So first, addition property of equality. And so that was where you started with an equation and you could add something to both sides. So like x minus 3 equals 7, we would add 3 to both sides to solve that equation. So in an equation, to keep the equation true so that it holds true, if you add something to one side, you have to add to the other. Same thing for the subtraction property of equality, multiplication, and division. Those are all properties that you use now in geometry when we're trying to solve equations. You learned them last year, maybe even in pre-algebra 2 years ago. Division property of equality, which is the last one of the 4. Remember, you cannot divide by 0. Dividing by 0, very bad. It's undefined. You'll learn more about that when you get into calculus and even algebra 2 and pre-calc, what division by 0 looks like on a graph. All right, reflexive property of equality, A equals A. So it just means like if I have, we talked about this maybe with segments a couple of weeks ago, that segment ML, the length of it, would be the same as saying LM. That's reflexive property. Symmetric property, so 7 equals 3 plus 4 and 3 plus 4 equals 7. Symmetric. It works both ways. Transitive property, when you have 3 things, like we talked about this yesterday with proofs, as we were looking at syllogism, the law of syllogism. This is very similar to the law of syllogism. So if A equals B and B equals C, then A equals C. Substitution property, we use that quite a bit already, that I can take something and plug it in. For example, if you have something like 4A minus 3, and I tell you that A is 6, you use substitution to solve that expression, to find the value for the expression, because you replace A with 6 and then figure out what the expression value is. Distributive property, I know you've done this before. That's where you multiply through. If something is multiplied on the outside of a quantity on the inside, either added or subtracted, we multiply what's on the outside to every single thing that's on the inside. All right, we will use these properties to justify solving an equation. Now, I am fully aware that you guys know how to solve this equation. If I just gave it to you on a piece of paper, you could rock it out. So here's what we're going to do. We are going to follow those steps here in the left column. Under statements, we are going to go step by step showing our work. So if you had to show your work last year in your Algebra 1 class, guess what? It's going to pay off right here. If you didn't, then now is the time to learn. All right, so the first thing we will put down, the first statement, will be our given statement. So 2 times 5 minus 3a. By the way, if you need to pause at any time, back up, do what you need to do. Pause to write this down, that's totally fine. So 2 times the quantity 5 minus 3a minus 4 times the quantity a plus 7 equals 92. All right, so the reason is this is given. That's a good reason. That's my favorite reason. All right, so here's what we're trying to get to. Our goal in this problem is to get to a equals a number, right? Isolate the variable, know what the value of that variable is. All right, so let's go to step number 2. So your second step to get from this equation, this first equation, and get it simplified, you might say your next step would be to multiply through by 2 and by 4. All right, so justification on that, what's that called? It's called the distributive property. By the way, all those properties on the last page, probably should have told you this earlier, but I will have a copy for you to throw in your notebook if you didn't write those all down. If you did, great. It'll help you remember them anyway. All right, so 2 times 5 is 10, minus 2 times 3a is 6a. And then remember, we're multiplying a negative through here, so star that. Make sure you take that negative 4 through. So negative 4a minus 28. All right, so I'm taking negative 4 times 7, which makes it negative, or you can just write minus 28 equals 92. All right, so there is step 1, or going from 1 to 2. All right, so my third statement. Well, let's see. Probably the next thing we would want to do is combine like terms on this left side. We don't really want to move anything over yet. You can if you want to, but we like to kind of clean up first. So let's put things together that are alike. I see a 10 and a negative 28. So instead of writing 10 minus 28, I can put 10 minus 28 together and get negative 18. I just substituted, instead of 10, a positive 10 minus 28, I substituted negative 18 for that. So guess what my reasoning is? Yeah, substitution. All right, I'm also going to substitute what for negative 6a minus 4a? Exactly, a minus 10a. Still equal to 92. Justification, or my reason on this side, is substitution. All right, next. I want to try to get a by itself. That's my goal. So my next step would be, let's get rid of this negative 18. To get rid of it, usually we just do this business, right? We add 18 to both sides, and I'm going to write that. I am, but I'm going to write it next to it. So I'm going to have this, a negative 18 plus 18. So there's what I usually write right underneath that 18. Minus 10a equals, I added 18 to this side, so guess what I'm going to do over here? Add 18 to the right side. That's the addition property of equality. All right, number 5. Now we want to use addition property of equality. Now that we've used the addition property of equality, this is gone, and I can do something with this. I can put those together, right? So negative 10a equals 92 plus 18. So 92 and 8 is 100, plus 10 is 110. Now what did I do? I substituted 110 for 92 plus 18, so that's substitution. And my last step will be, you guessed it, divide both sides by negative 10. So dividing both sides by negative 10, and that is division property of equality. And last step, after I divide that, instead of, sorry, I'm trying to change colors here. Instead of writing, wow, what number comes after 6, Coach Lowe? 7. Okay. Instead of writing negative or positive 110 divided by negative 10, I can go ahead and substitute. 110 divided by a negative 10 is a negative 11. So again, substitution property. And I don't mind you abbreviating, by the way. All right, or you could just write substitution on that, totally fine. I'll go ahead and put property at the end of these, probably would be better. All right, hopefully that makes sense. Let's do one more, a little geometry mix here. This one's a little bit shorter, but hopefully you see justifying each of those steps, kind of throwback Algebra 1 and justifying what you did. All right, last one. If angle A is congruent, and if you don't know how to read this, we need to learn, okay? If angle A is congruent to angle B, so that means congruent, which also means equal in measure, then the measure of angle B is equal to 2 times the measure of angle C. So angle B is twice, whatever angle C is, it's 2 times that measure. And the measure of angle C is 45 degrees. Then the measure of angle A equals 90. All right, so all of this stuff here is my given. Right, that's the given part. This at the end is my goal. That's what I want to try to get to. All right, so I'm always keeping my eye, always peeking back at that goal, keeping my eye on it. All right, my first statement is my given. So notice I have an if-then statement, right? So I'm going to write down my hypothesis. Angle A is congruent to angle B. We know by definition, and we'll write this down in a minute, that that means those are equal in measure. The measure of angle B is equal to 2 times the measure of angle C, and the measure of angle C is 45 degrees. All right, reasons given. All right, so let's think through this process. If my goal is to show that angle A is 90 degrees, well, let's look at what's linked here. I know that angle A and angle B are congruent. I know that angle B is 2 times the measure of angle C, and I know what angle C is. So I'm thinking if I go backwards through this, or if I could link these together, if I could substitute the measure of angle C here, I know that would be 90 degrees, and I know that angle A and angle B are congruent in measure, which means, congruent, which means they're equal in measure. So 2 times 45 is 90. That would fix it, right? The measure of angle B would be 90 degrees. Angle A and angle B are the same measure, so that makes angle A 90. All right, so we know how this is supposed to work out. Let's make it work out. All right, so the first step, we're going to say the measure of angle A, so let me slide an M in front of this. The measure of angle A is equal to the measure of angle B. And we talked about that's exactly what that congruent symbol means. So this is definition of congruent angles. Man, that's some squiggly writing. This is supposed to be squiggly though. All right, definition of congruent angles. Like my abbreviation? Good, you can use it. All right, so third step. All right, so we know now, since those two are equal, that we can actually substitute right here. If angle A, the measure of angle A is the same as the measure of angle B, then that means the measure of angle A is also equal to 2 times the measure of angle C. Now, what did we do? One of the things we did was we substituted, but that can also be transitive property, right? The measure of angle A is equal to the measure of angle B. The measure of angle B is equal to 2 times the measure of angle C. Therefore, the measure of angle A is equal to 2 times the measure of angle C. So that's transitive property. We had 3 things we were working with there. All right, number 4. We are getting close already. This is awesome. All right, so we know the measure of angle C from our other given statement. We know what that is. So the measure of angle A is equal to 2 times, we know what the measure of angle C is. It's 45. What did we do? We substituted. Yay. All right, and almost the last, no, this is the last step, right? We're almost finished, huh? All right, last step would be to substitute again, because we know that 2 times 45 is 90. And that's substitution again. And we are finished. Look, that was our goal. We should have been peeking back at that the whole time. We talked through our steps before we wrote them down, and we met our goal. So we say, bam, yes. All right, guys, this is Coach Lowe, and I'm out.